Good morning, everyone, and welcome back to 61, 67, 81, and 67. And in this session, we are going to continue to introduce the security of software-defined networks. So in the previous video, we introduced a very important thing that we have been, assumed that it is true in SDN, which is how does the controller learns the network topology. Okay, so specifically we introduced two things. One is how do we understand what happens to the host, and the second is how can we figure out the link between switches. Okay, so that sounds reasonably easy, right, based on the previous description. And the host is connected to a switch. And if the host move, when it sends out the packet will go to another switch, and the switch just report to the controller. The controller update its record. Fair enough. It's like, hey, I have moved. So you go to the post office, said, hey, I have moved, so please forward my mail to this address. Okay, if you recall, if you are moving or if you are changing your mail forward address at the post office, do you just walk in and you can just change whatever you want to change? In other words, can you get into the post office, said, hey, why don't you forward President Donald Trump's mail to my address at this because I'm Donald Trump? Of course, the post office will not tolerate that. The post office will say, oh, you want to change the address for Alice? And who are you? Oh, I'm Alice. Great. Why don't you show us your driver's license? So in other words, you are authorized to change your own address, but not anybody else's address. So what we're saying here, we are saying that, hey, if you are moving and if you want to change your profile, so in this specific example, it is your post office profile, we need some authentication mechanism. Make sense? Of course it makes sense. You are changing my record. I need to do some authentication. Now let's go back to the software-defined network. Okay, so if the host moves and we need to change the host profile, if you recall, in the controller, if we need to change the host profile in the controller, and of course, God forbid, if possible, we should have some authentication. But actually, we face some challenge. And this is the challenge to authentication between host and also the controller. Why is that? Remember, the motivation application of the SDN that we introduced is the data center. Okay, for the data center, you have a lot of servers under your management. Remember, if we are talking about, let's say, Amazon's cloud service, or Microsoft's cloud service, or Google's cloud service, all the servers belongs to Amazon. Okay, belong to Amazon. At the same time, the SDN belongs to Amazon as well. That basically means all the switch belongs to Amazon as well. Okay. So if the switches and the servers belong to the same owner, then that is relatively easy. Why? Because the owner of the SDN will enforce that, okay, we are going to do authentication, okay, and this is the public-private key pair for every of the device. If you're a switch, I will give you a public-private key pair. If you're a server, I will give you a public-private key pair as well. And if you're moving and if the connection changes, I will need you to digitally sign everything that you exchange. However, what are we talking about now? We're talking about host. Remember, the host is the general user. Okay, that basically means, hey, I'm just getting a virtual machine on Amazon's cloud and I'm conducting some computation. And of course, it's possible that my virtual machine needs to be moved from one server to another server. At this case, Amazon has no authority said, oh, you're a new user to our cloud? Great. This is a public-private key pair, and we need you to use this public-private key pair and this digital sign algorithm. Under no circumstance, Amazon will have the authority to force me to use this type of condition. So that basically means, oh, we have a host that is connected to the SDN through the switches. However, we do not have a uniform mechanism for authentication between the host and the SDN network. Is that the truth? Is that the truth? Is that the case? Let's take a look at the real life example. Okay, and we come back to this paper. Okay, and we're looking at the slides, and hopefully we can find. Here we go. Let me reduce the size. Okay, this is the host profile that the SDN controller maintain in their record. And on the left side, you have all the mainframe or the big controller software that was running outside. Okay, and you can see this is Open Daylight. I believe this is IBM. And the Knox, I believe we introduced in the previous paper, and it's called a fortified Knox. So you remember, these are all the some major or open source controller software running outside. Okay, and then let's see what they're actually using to uniquely label a host. Remember, the red ones are the information that the controller is using to uniquely label a host. What are they using? MAC address, MAC address. Oh, by the way, some of the black information are also remembered by the controller. Okay, the characters in black. For example, in the Knox controller, they also need to remember the location. So at which switch and which port it's connected. So surprisingly, what did you see? You see most of the host profile, they are using MAC address to uniquely label a host. Well, this is actually natural, right? Can we use IP address? We cannot use IP address for sure. Why? Because it's very possible that it's a DHCP IP address that is dynamically allocated to me. That basically means if my virtual machine moves from one server to another server, my IP address will change. So I cannot really use the IP address to uniquely label me. So what should I use? I'm going to use the hardware address. That will be much easier, okay? Because this thing will not change. Well, as soon as we figure out that, oh, actually a lot of the software-defined network controller are using MAC address to uniquely label a host, what does it mean? We are using MAC address to uniquely label a host? Of course, we are going to face the spoof attack. Why? Because what is a MAC address? The MAC address is just 6 bytes. Okay, I can put whatever MAC address I have or I want to put in the packet that I send out. And I can use this to fool the system. So let's take a quick look. This is the controller, okay, because somehow my my welcome the pen and the panel is not working very well. So let's just take the controller for C. And of course, they have server 1, server 2, server 3, server 4. And of course, we have a host connected to server 1. So what if I'm an attacker? remember, at this moment, I'm just a Amazon Cloud user. I don't need to control. I don't need to grab the control of the controller. I don't even need to grab the control of a switch. I'm just a general user, okay? But I have full control over my virtual machine. And I'm going to send a packet out with the host's MAC address. I can easily send things out to impersonate the host. And then, of course, S2 as a switch will learn that, whoa, this is a new MAC address I have never seen. So what should I do? I need to report to the controller. And the controller will look at the host profile, the HP, the host profile. By the way, this is not the computer manufacturer HP, it's host profile. The controller will check in the host profile, said, oh, I have seen this MAC address. Well, it moves. It used to be associated with server 1, but now it moves and it is associated with server 2, and I can do that. Fantastic. As soon as the host profile change, a lot of things will change as well. For example, this will actually become a DOS attack. Why is this a DOS attack? Because now the controller believes that the host is here, so if there is a packet coming to the host, I will need to forward it to this guy, and this guy will forward to the attacker, okay? And what will the attacker do? The attacker can choose just to silently discard the packet. It will become a packet black hole that will become a DOS attack. What else? It could also conduct a man-in-the-middle attack. Of course, this is exactly like the ARP poisoning. I hope your memory about the first half of the semester is still there, okay? So what we're doing here, we are actually conducting a ARP poisoning attack. It's just in the SDN, okay? The reason that this attack will lead to the DOS, denial of service attack, or man-in-the-middle attack is because the controller is only using the MAC address to uniquely label the host. And we can impersonate it. So now if the packet is coming to us, and the bad guy attacker can choose, oh, I will just somehow forward to the host. Okay, so in this way, the packet will first come to me, and then I will decide whether or not I send it to you based on the content. So now it becomes a man-in-the-middle attack. It becomes a man-in-the-middle attack. Okay. So with this quick introduction, let's go back to the slides and to go through the slides quickly and introduce this type of attack. So now I believe you have get the meaning of this attack. Okay. This attack is called poisoning network visibility in SDN. And how can they poison the global view of the controller, of course. Okay. So these slides we don't have to worry about because they're basically introducing how the SDN works. And we have finished introducing the first attack, which is host location hijacking attack. In other words, we are poisoning the system so that it will have a misunderstanding of where the location, where the host is. Okay. So let's see. We assume that the attacker controls a collection of compromised hosts or virtual machines. Okay. Remember, here we do not need the bad guy to control any switch, and they don't have to have the capability to grab the controller. Well, if they have the capability to grab the controller, then we're totally cooked. Okay. So this is the host tracking system we just introduced. Okay. And the controller will maintain the host profile, and here we introduce, surprisingly, they are using the MAC address, and also there is no way we can achieve effective authentication because the host could come from all directions in the network. Okay. So the problem is when the authors of the paper study the implementation of the SDN controller software, they find out that very few security restrictions for host location update. So basically, you just need to send out a packet, and the host profile will be automatically changed in the controller. Okay, this will allow the attacker to impersonate network identity through spoofing the MAC address. Okay, and here we just show how this attacker sent out the packet to fool the controller in the SDN. Okay, and of course it will lead to the attack such as man-in-the-middle or at a denial of service attack. Okay, so how can we defend against attack? Remember, we are security guys. Okay, while we are worrying about the cyber attacks, we always need to consider the defense that we have to worry about. Okay, so let's see, what about the defense? Actually, there are two possible ways to achieve the defense. The first way, of course, is the digital signature. So whenever a host moves, you need to provide the corresponding authentication mechanism. It could be the digital signature. It could be a shared key between you and the controller, or between you and the switch. Okay, and if you recall, in the previous video, we just introduced that, it's fairly hard for you to actually generate the digital signature. Okay, we can somehow enforce the host. You remember, so let's say you create a VM in Amazon's cloud. Okay, we cannot force you to use certain type of digital signature algorithm. However, if you're a user of Amazon, we definitely have a mechanism to authenticate who you are. Okay, so if you are sending out, or if you are moving these virtual machines, we will need you to accomplish a re-authentication procedure. Okay, that's a fair requirement. The second approach will be transparent to users. What does that mean? It basically means, hey, if we move you, you don't have to do, you don't have to input the password again. Okay, we will authenticate, we will verify the movement. Here, the system is not verify the user or the host. It is actually verifying the movement. What does it mean? This is switch 1, this is switch 2. The host move from switch 1 to switch 2. What does that mean? That means if I ping host from switch 1, it should not respond. And also, the link layer, from the physical device link layer, I will figure out that, okay, this port is actually down. Why? Because this host has unplugged its cable. So this port, this interface will actually become down. So this is the verification of the movement or change of the network topology. So if there is a move, the switch 1 will verify whether or not the link is down, and whether or not you can still reach the certain host. Okay, under that case, if I am the impersonator, if I am the attacker and I claim that I'm the host and I move here, but the switch 1 can still reach to the host from this link, then the system will know that, oh, there is something wrong. There is something wrong. Okay, so I hope with this set of slides, so let's go to here. So verify the legitimacy of the host migration. Precondition check, you're going to see whether or not there is support down signal, and also whether or not you can still reach the previous location, reach the host from the previous location. Okay, with this video, we introduced the host location hijack attack in SDN network and how do we defend against it. And I hope this helped you to understand the first half of the slides. I will see you in the next video. Thank you. Bye.